Hello everyone. So again here is a question on Jahn Teller distortion. So again I would request everyone to go through this concept first before trying or attempting these kinds of questions. You read the theory, what are the conditions for Jahn Teller distortion, what is asymmetric filling of d orbitals, how the distribution of d orbitals in the T2g and EG orbitals after crystal field splitting. So these kinds of distributions, how they occur and what are the conditions that lead to Jahn Teller distortion of the regular octahedral geometry. So all of these things, please go through it from your convenient resources, maybe books, tutorials, videos, whatever, and then you can follow this video where I will solve this particular question. Okay, so let's get started on this note that you have knowledge, some knowledge of this background on Jahn Teller distortion. So the question says that the set of ions expected to show Jahn Teller distortion in their complexes is, so we have four options. We have different ions: titanium 3, copper 2, high spin Fe3. Option B has copper 1, nickel 2, high spin Fe3. Option C has copper 2, low spin Fe3 and titanium 3. Option D has low spin Fe3 and manganese 2 and copper 1. So we will check out all of these one by one and then we will see the distribution of the d electrons. So first of all, in the first set we have titanium. So what is the ground state electronic configuration of titanium? It is 3d2,4s2. And then in the plus 3 oxidation state it becomes 3d1,4s0. Okay. Then in the same set we have copper. We know that ground state electronic valence electronic configuration of copper is 3d10,4s1. Now what about copper 2? So it is copper 2 is 3d9,4s0. Okay, now in the same set we have high spin Fe3. So Fe in ground state has 3d6,4s2 valence electronic configuration. Fe in the plus 3 oxidation state will have 3d5. Okay. I am indicating the s orbitals as 0 so that there is no confusion, and we also get to know that we have another orbital next to d. Okay. Then in the second set what we have? In the second set we have copper 1. So we know that copper in the ground state has 3d10,4s1. So copper 1 will be only 3d10. Now in the option B we have next one is nickel 2. So nickel ground state electronic configuration is 3d8,4s2 and nickel 2 will be only 3d8. Now in the option B, the last set we have high spin Fe3. So again it will be 3d5 as we have high spin Fe3 in option A also. So 3d5. Okay, now coming to set C. We have copper in the second oxidation state. So it is repeated again as we have in set 1. So we know copper 2 will be 3d9. Then in option C, we have low spin Fe again. So we have low spin Fe3. Fe3 has 3d5. Low spin, high spin distribution we'll see later. Okay, so Fe3, 3d5. Then in C, what else we have? We have titanium 3 again, which we had in option A also. So that will be 3d1. Okay. And then coming to the last set D, we have low spin Fe3. So low spin Fe3 again will be 3d5. Then in option D, we have Mn2. So manganese is 3d5, 4s2 in the ground state. So in the second oxidation plus 2 oxidation state, manganese is 3d5 only, 4s0. Okay. And then in option D, we have the last one as copper here, copper 1. So copper 1 we already saw in option B as 3d10. Okay, now we will check out the distribution. So again going back to option A. So here you can see option A has titanium 3 and it has 3D1. So the distribution into T2G and EG orbitals. Okay, so this is T2G and EG. So in case of titanium, we have one electron. So here, obviously T2G is unsymmetrically filled. Okay, here unsymmetric filling. We just have to check that in which option we have all such kinds of ions where the either T2G or EG is unsymmetrically filled. Only those will give us the Jahn Teller distortion. Okay, so in case of titanium plus 3, we have this unsymmetrical filling. Then copper 2, 3D9. Okay, so how do we fill the 9 electrons in copper? So like this, first singly occupied 5, 6, 7, 8 and 1, 9. So here also EG is unsymmetrically occupied. We have 2 electrons in one orbital and 1 electron in the other orbital. So this is unsymmetrical filling. Now in option A, we have another ion which is Fe and which is high spin Fe3. So 3d5 high spin means the electrons are unpaired, weak field complexes. Okay. So high spin means each orbital will contain one electron each without any pairing. So you can see here that for D5 configuration, we have the high spin D5 configuration. We have T2G also symmetrically filled and EG also symmetrically filled. So in option A, this option will not show Jahn Teller distortion. So option A is neglected. Although Ti plus 3 and Cu plus 2, they show unsymmetrical filling of d orbitals, but the high spin Fe3 does not show unsymmetrical filling. So that is why this complete set is not distorted one. So here Fe3 high spin will not show Jahn Teller distortions. So option A is discarded. Now what all ions we have in option B? In option B we have Cu1. So Cu1 means 3d10. So 3d10 has no chance of asymmetric filling of d orbitals because all the 10 electrons completely occupy the T2G and EG orbitals, leaving them fully filled. So this option is gone. So to decide quickly that which option should be the correct answer, so option B is also not the correct option because one of the ions we have symmetrical filling. So no need to see the nickel 2 and high spin Fe. We already know how the electrons were distributed in option 1. So they were symmetrically distributed. So this high spin Fe will also be symmetrically distributed in option B. So option B is also discarded. Okay, so this is how we quickly decide. Then move on to the next option. Okay, next option what we have? We have copper 2. Copper 2 from option A, you can see copper 2 shows unsymmetric filling of EG orbitals. We have 3d9 configuration, 6 electrons in T2G and 3 electrons in EG. So this one copper plus 2 should show Jahn Teller distortion. Okay, asymmetrically filled EG orbitals. Now in option C, what else we have? We have low spin Fe3. Okay, once we saw high spin Fe3 which contained 5 D5 unpaired electrons. Now what happens in low spin? The D5 electrons are paired. Now let's see what happens when these are paired. So when these are paired, that means it stays in the T2G 1, 2, 3, 4 and 5. So that means when it is low spin and pairing occurs, then we have an unsymmetrical filling of the T2G orbital. This unsymmetrical filling of T2G orbital shows Jahn Teller distortion. That means low spin Fe3 complexes should show Jahn Teller distortion. And now the third ion in option C is titanium 3. Yes, titanium 3 also shows Jahn Teller distortion. Here we saw titanium 3 contains D1, 3D1 electrons which are unsymmetrically filled in T2G orbital. So option C, which has copper plus 2, low spin Fe plus 3 and titanium plus 3. All of these contain unsymmetrically filled either T2G or EG orbitals, which show Jahn Teller distortion. So option C should be the correct answer in all probability. But let's check the option D also for our satisfaction. Let's check it. So low spin Fe3. Option D has low spin Fe3. Yes, it will be unsymmetrically filled. Just now we saw low spin Fe3 unsymmetrically filled T2G. Then manganese 2. What about manganese 2? Do we have manganese 2 anywhere? Yes, 3D5. So manganese 2, it's not given whether it is low spin, high spin. Okay. So manganese 2, 3D5. So if 3D5, just like Fe, so Fe3. So all the 5 electrons are symmetrically filled in T2G and EG orbitals. So manganese 2 will also be symmetrically filled. So it will not show Jahn Teller distortion. Then we have copper 1. Okay, copper 1 we have seen in option B. It is 3D10 electronic configuration where all the 10 electrons are completely filled in the T2G and EG orbitals. So copper 1 will also not show Jahn Teller distortion. So option D is not the correct option. So A, B and D are not correct because in A, B and D, 1 or 2 options we have one of the ions which are symmetrically filled in the T2G and EG orbitals. The electrons are symmetrically distributed. Only in option C we have copper 2, low spin Fe3 and titanium 3 where all the 3 ions have one or the other, maybe either T2G or EG which is unsymmetrically filled. So option C is the set of ions that will surely show Jahn Teller distortion. So I hope this explanation was clear to you, and it's not a tough question. If you have some basic knowledge about Jahn Teller distortion and the conditions leading to these distortions and how the symmetric and asymmetric filling of T2G and EG orbitals occur, then you can solve this question very easily. If my video is helpful to you, please like, share and subscribe. And please let me know in the comment section what you want to learn next in chemistry. Thank you so much.